perfect square trinomial. It's not a page, we're just taking notes. Alright, a perfect square trinomial is a trinomial that came from squaring a binomial. Okay? A perfect square trinomial is a trinomial that came from squaring a binomial. So if you have like x plus 2 squared or x minus 3 squared, those are binomials that we square and they become perfect square trinomials. So this one, if I multiply this out completely, okay, this one would be x squared plus 4x plus 4. This one, if I multiplied it out, it's going to be x squared minus 6x plus 9. Okay? These right here, these two things, they are perfect square trinomials. Here's the thing with perfect square trinomials that is not the same with other things. If you look at that and you don't recognize it as being a perfect square trinomial, you can still factor it anyway. You can say, okay, well, let me look at this. I need two numbers that multiply to equal 9 and add to equal negative 6. What would those numbers be? Negative 3 and negative 3, right? So it factors down to x minus 3, x minus 3. And then you go, oh, crap, that's a perfect square trinomial. I could have saved myself some time if I recognized that. You can still get the answer with a perfect square trinomial, even if you don't recognize it right away. Some of them you can't. Like the sum and difference of cubes that we're going to look at in just a second, that's a formula that you have to memorize. You got to memorize it and recognize it. That's the only way. Okay? These, you can still get it. Perfect square trinomials is just a way to save you some time. So let's talk about how to recognize a perfect square trinomial. What? Isn't that crazy? Alright, recognizing a perfect square trinomial. Okay, first of all, how many terms will it have? 3, because it's a trinomial. You get that? You get it? Okay, it's a trinomial. So it's going to have 3 terms. The first term and the last term will be perfect squares. It's amazing how that works. See, math people are not creative, okay? We name it exactly what it is. We don't make up stuff like onomatopoeia. That's not a real word. Someone made that up, okay? It's like, let's see how many vowels we can put in one word. No, we name it what it is, okay? So, perfect square trinomial, the first term is going to be a perfect square. That's an A. It's going to be anything squared, okay? The last term is going to be a perfect square, something else squared. Alright, give me a perfect square. What's a perfect square? What? 81. So this is going to be 81x squared. What's another perfect square? 25, okay? Sorry, we'll use yours next time. I'm not listening to you, Alabama shoes. Okay, so perfect square, perfect square. So we're looking at our work and we notice, hey, that's a perfect square and that's a perfect square. But the middle term also matters, okay? The middle term this term right here is going to be 2 times the square root of the first times the square root of the second. So the middle term, what's the square root of 81?
9.
What's the square root of 25? The middle term is going to be 2 times 9 times 5. It's not 8, 6. So you look at this and you go, hey, okay, I've got 3 terms here, and I know this is a perfect square, and I know this is a perfect square. Now, what is 9 times 2 times 5, or 5 times 9 times 2? Doesn't matter. It's multiplication. Order doesn't matter. Well, I know that 2 times 5 is 10, and 10 times 9 is 90. Hey, this is a perfect square trinomial. It's going to factor down to 9x plus 5 squared. Save yourself some time. Let's say you didn't recognize that and you have to multiply this out. Okay, what's 81 times 25? No one knows? No one has a calculator? I'm going to say that it's, let's see. So you need 2 numbers that when multiplied equal 2025, and when added equal 90. It's 45 and 45. Alright, when you're factoring it out, and these 2 numbers are exactly the same, that should be your next clue, that you're dealing with a perfect square trinomial. If you didn't recognize it here, once you get here, and you're like, oh, they're exactly the same, that's awesome. Yeah, it's awesome, because it's a perfect square trinomial. Okay? Save yourself some time. Because then you're going to keep factoring. You're going to go, okay, so let me see. 81x squared plus 45x plus 45x plus 25, group. And on this, I can take out a 9x, and that leaves me with 9x plus 5. And over here, I can take out a 5, and that leaves me with 9x plus 5. Oh, look. Isn't that neat? 9x plus 5 on the inside, and 9x plus 5 on the outside. Yeah, because it's a perfect square trinomial. Look how much time you wasted. Because you know you're not going to come up with 45 and 45 right away. You're going to list all the factors of 2025, or you're going to skip it. Or you're going to get online and try and find the answer. Either way, you wasted a whole bunch of time. Alright? Perfect square trinomial. It can be worked the other way. But if you can recognize that it's a perfect square trinomial, you can save yourself so much time. Okay? Middle sign right here. See that sign right there? If it's a plus sign, you're going to put a plus sign right here. If it's a minus sign, you're going to put a minus sign right here. I mean, that's that easy. If it's just, see over here, x plus 2 ended up with a plus sign, and x minus 3 ended up with a minus sign. If you look at this, and there's a minus sign, then when you factor it, you put a minus sign. When you look at this, if there's a plus sign, then you put a plus sign. Okay? Those are perfect square trinomials. If you don't recognize it's a perfect square trinomial, you're not automatically going to miss it. You're just going to waste a lot of time that you didn't have to waste, okay? And we are working towards doing higher order polynomials that each page, or each problem will take up about a page. And that's not a lie. That's not, like, I'm not even kidding you. Each problem will take up about a page. And each problem will take like 10 to 15 minutes. So any little bit of time you can save yourself would be awesome. Okay? Perfect square trinomial. Alright? Alright, now let's look at the sum or difference of 2 cubes. Okay, this is one that you're going to have to recognize, okay? This is not one that you're going to be able to just do if you don't recognize that's what it is, because it's not a quadratic. Remember, the x factor, factoring, only works with quadratics. This is not a quadratic. See the name? It's a cubic, okay? And the factoring that we do works with quadratics. You've got to recognize that's what it is. You better recognize. Okay, so you're going to have basically two cubes. We're going to do addition first. You're going to have two cubes being added together. Something cubed plus something cubed. What's a cubic? What's a cube? Not a geometry. What's a cubic number? Anybody know? Any examples? Here's an idea. Take a number, multiply it by itself 3 times. That answer is a cube. Okay, go. 8. 8 is a cube because 2 times 2 times 2 equals 8. Okay, so there's a cube. So let's say that this first number is 8x cubed. That has to be cubed. If it said 8x squared, it's no longer cubed. Everything has to be cubed. Plus, okay, give me another example. Give me another cube. 20 what? 27. Yes, okay. Wonderful. What's the cube root of 27? 3. Okay, so we're looking at, as far as cube roots go, this one is 2x, and this one is 3. So I'm looking at that, and I'm working, and I see this, and first of all, my first tip to me in recognizing what this is that that ain't no square, right? That's a 3. That's a cube. So I cannot do my little x factor and multiply and see what it means to multiply to and add to. It's not going to work on this one because that's 8x cubed. So then I need to kind of look at the numbers. Okay, well, 8 has a cube root of 2, and 27 has a cube root of 3, so I'm looking at a sum of 2 cubes. That's what it is. Okay? And 2x is the A, 3 is the B. Now this formula that I'm going to give you, you have to memorize. You have to memorize it. There's no other way to get it. It has to be memorized. Okay? A cubed plus B cubed will factor down to A plus B times A squared minus AB plus B squared. I want to get that written down, and then we'll see how this turns into that. You have it written? Okay. I love these. All right. So what's in the A place? A. What's the A? 2x. What's the B? Now A squared. What's 2x squared? 4x squared. Minus A times B multiplied together. 6x plus B squared. What's B squared? 9. That is your factored answer. That's your factored answer. Alright, so that's your factored answer. What's great about this is if we can get it to this point and we're trying to find zeros, we can find that zero really easily, and now we have a quadratic, and we know about, I don't know, 1,000 different ways to solve a quadratic. So that's the sum of two cubes. Let's talk about the difference of two cubes. Let's say you have a cubed minus b cubed. So we're looking at 8x cubed minus 27. What's a over here? 2x. What's b? It's 3. You're welcome. This time we're going to be looking at a minus b. A squared plus ab plus b squared. What's the difference in these two formulas? The signs split, they change. Alright, up here it was a plus and now it's a minus. Right here, that one was a minus and now it's a plus. Okay, so your signs are different and you've got to keep them straight. You have to memorize these in your head. They have to go in your brain, no cheat sheet, not written on your hand, not on your arm, not saved in your calculator, not on your phone. They have to be in your head. Yeah, you have to memorize them. Okay? So, if I want to factor this out, what's a minus b? What's in the a place? What's in the b place? Times a squared. What's that going to be? 4x squared plus ab plus b squared. That's what those factor down. Okay, and how are you going to figure these out? Everybody know? Memorize and recognize. You have to memorize the formulas, and you have to recognize that they're the sum or difference of two cubes. Because it's not going to be, when we do our actual test, or when we start doing these and finding zeros of polynomials, it's not going to be just there. Like, oh, this section is just sum or difference of two cubes. This section is perfect square trinomials. This section is difference of two squares. It's not going to be like this. They're all going to be mixed in together. So you have to have the formulas memorized, and you have to recognize that's what it is. Now on the homework for practice, everything's separated. It's in its own section. When we start working with these, and we're no longer just practicing how to do these, but we're actually applying them to other things, it's just going to be like factoring soup. You're just going to dip your spoon in and pull out whatever. Okay? That's what's going to happen. All right? Any questions about sum or difference of two cubes? Where does the A come from? Where do I get A? The first number. It's the cube root of the first number. Where do I get B? Cube root of the second number. How do I know it's a sum or difference of two cubes? Plus or minus what? Cubed numbers. Like these have to be cube numbers. Okay? And what is a cube number? A number that has a cube root. Okay, great. Look back at 4-4.